Why can't we solve these problems? We know what they are. Something always seems to stop us. So I started to go around the world finding the best and brightest scientists I could at universities, whose collective discoveries have the chance to take us there, and we formed a company to build on their extraordinary ideas. 6.5 years later, 180 researchers, they have some amazing developments in the lab. I will show you 3 of those today, such that we can stop burning up our planet. And instead, we can generate all the energy we need right where we are, cleanly, safely, and cheaply. Think of the space that we spend most of our time. Tremendous amount of energy is coming at us from the sun. We like the light that comes into the room, but in the middle of summer, all that heat is coming into the room that we're trying to keep cool. In winter, exactly the opposite is happening. We're trying to heat up the space that we're in, and all that is trying to get out through the window. Wouldn't it be really great if the window could flick back the heat into the room if we needed it, or flick it away before it came in? One of the materials that can do this is a remarkable material, carbon, that has changed its form in this incredibly beautiful reaction, where graphite is blasted by a vapor, and when the vaporized carbon condenses, it condenses back into a different form. Chicken wire rolled up. But this chicken wire carbon, called a carbon nanotube, is 100,000 times smaller than the widths of one of your hairs. It's 1,000 times more conductive than copper. How is that possible? One of the things about working at the nanoscale is things look and act very differently. You think of carbon as black. Carbon at the nanoscale is actually transparent and flexible. And when it's in this form, if I combine it with a polymer and affix it to your window, when it's in its colored state, it will reflect away all heat and light, and when it's in its bleached state, it will let all the light and heat through, and any combination in between. To change its state, by the way, takes 2 volts for a millisecond pulse. And once you've changed its state, it stays there until you change its state again.